So, at the beginning of my presentation, I would like ask you how many of you are running IPv6 in your network? A lot of you. And because people don't like put their hands up, how many people don't run IPv6 in their network? One hand, two hands. Oh, it's good. So you might be interested in this topic. This presentation will be about new issues that we have in IPv6 world related to user identification in the network. What is new in IPv6? In IPv4, we had a very simple situation because usually one IP address means that is one user, one computer, and any tracking of this data was pretty easy. The IPv6 brings some new auto-configuration mechanism for local network that's known as privacy extension. That means that computer creates own address every time you connect to the network, and this address is periodically changed. So there is an image of the one computer that was run for 7 days, and in these 7 days, this computer created 7 different IP address, and this computer is able to communicate with this address anytime that is needed. This chart shows the progress in communication with those address. At the top line, we see one link local IP address for this computer. The second line is IPv4 address, so we can see that this usually turns up at the morning and turns down later, and we see that in IPv6 world, this computer uses different IP address and in different times. What put us in the very difficult situation when we try to track this computer and make some statistic related to this computer or this user. Because if we try to make some filter into, for example, NFDump, we have to create this condition into filter to filter out only this one computer, and there are difficulties if we made some aggregation and top-end statistics, so we are not able to do it with this behavior. And we also have another question. We have IP address, for example, with security incidents, and we try to find who this address belongs to, because we have to find the proper user who was using this IP address. How it worked in IPv4? As I mentioned, in IPv4 it was pretty easy because we usually had one IPv4 address, and this address was in most of networks tied with MAC address of computer. So we know this computer is usually used by this user. We have database with MAC address. We have this static record in DHCP server for this IP address, and we know that this user usually use this IP address. And there was another good thing, that one computer usually had one IP address and at time. So it's not true in IPv6 work. So do we have any proper solution for this thing? Not at all. Many people think that authentication on layer 2 on switches can solve this problem, but that's not true at all, because we don't have a relation between this authentication, which is based on a MAC address, and IPv6 address. We don't have this information, for example, in Radius server. Also, we can use the DHCP version 6 environment, stop this auto-configuration issues, but there is another problem, because the DHCP version 6 don't use a MAC address as an identifier, and use special host identifier that is created randomly, and we can predict this number. So we also lose this relation between MAC address and IP address. And there is another problem, as I said, one host can have more IP address in one time. So what we try to do in our project, only recapitulation, we all knows what the flow record is. There are some key fields like source and destination address, source and destination port, and some non-key fields like number of bytes and number of packets. In our project, we tried to extend this flow record with another level of information, like, for example, mentioned IP address. But we don't have to stop in MAC address. We can also, with knowing this address and relationship between address and MAC address, extend this information, for example, about the information where was the user connected to. So we can extend with the switch port. And another level could be we can extend this flow record with user ID, not login, but some number identification of this user. When we can get this information for particular data. The mapping between IPv6 address or IPv4 address and MAC address we can get from neighbor cache or ARP table. Is the information that every router in the network have to have because it's necessary to operate the network, and there is only problem how to get this data. We at all have two possibilities. The first one is get this data from the router, for example, through SNMP protocol. There are two MIPS where the data should be stored. Or we have another opportunity to make passive monitoring at the network, listen ARP and neighbor cache, neighbor discovery packets, and store this information into some database. So we have first level of this data. If we need another level of data, that we would tie a switch port and MAC address, for example, we also have a possibility to get this data from switches. There is forwarding database, and there are some standards which defines where we can find this data on the switches. And another level is relationship between MAC address and user identification. If we use layer 2 authentication, we can get this data from a radius server, or what is typical for many networks, they use own database where they register their users, put MAC address into database and IP address, so we can use external source for this purpose. We created some architecture of the system that could make all these things that I thought about. It doesn't look nice at this, so we can divide it into several parts. The basic data source are NetFlow data taken from ordinary probes through NetFlow or IPv6 export. In our cases, we use Flowmon probes with cooperation with guys from Inveatech. We created our own solution because we are using HP platform, and we created with HP and Inveatech blade module that we can put into switch, and this blade module have direct access into backplane of the switch. So there is Flowmon running on this blade. This blade is ordinary piece with two 10 gigabit ports. So there are also pictures how it works in operational state, but there is nothing special on it. There are just regular NetFlow data. As the tool for processing data, we were thinking whether we should create own tools or use tools that already exist and they do good job. So we start using NFDump for this purpose as the NetFlow collector. So actually we have 3 points where we get NetFlow data. 2 of them are on the upstream line where the university is connected to the testnet, and one we have on the students' dormitory. It's a rather experimental point, but it's a very interesting point because we have most of data on this switch where students are connected to. There are peaks about 4 and 5 gigabits per second. So it's very, very useful for special performance testing. And another tool that we used is tool for getting data from devices, from switches and from routers. And we start using another tool that will be presented, I think, today later. It's nav, because this tool already can do all these things that we needed in our system. There are only few views to nav system. The nav system have some database of devices that we use in network, and what is important for us, they have this relationship between MAC address and IP address with times, and it's exactly what we needed in our project. So we have data, we have sources for this data, we have some tools how to put this data together, and yeah, another, I forgot to mention it, we created our own plugin for Radius server that gets data from Radius logs and put into database that is, this database is same for nav and Radius, so we share this, we extended this database for nav about this data from Radius server. So we have this architecture. We have several sources of data. So we have NetFlow data from NetFlow probes, some SNMP data directly from devices that operate on the network, and some external data about users from Radius servers that we operate. And now is the problem how to put all this data together to have some valid information. At the first stage, we use our special tool, NF tool, that updates NetFlow files and add this information into this data that we already have from NetFlow. For MAC address, it was pretty easy because NetFlow already have items for MAC address, so we only add this information into existing NetFlow data. With user identification, we have a little bit problem because there is no column for this data. And in the first phase we used for this purpose, MPLS tag is not correct, but we only try to check if the system works at all. And in the second stage, one of our colleagues created patch to NFDump and extended this tool about new items where we can put user identification. How it works. So we have flow data from NetFlow probes. This NF tool takes data from nav database where the data are stored, and output are again NetFlow data in NFDump format. And what is great with all these things, we can steal all the power that NFDump have for querying data. So all aggregation, filtration, top-end statistic, etc. We don't have to develop our own tool. We can use tool that is already here, that everybody knows how to use it, and we don't have any extra effort with that. So there are some examples of queries how we can ask NFDump for data. So the first line shows we are interested in data from one computer with this MAC address, and no matter which IP address was used in communication. We also can make some aggregation, and if we have in the system data about the users, we can use this command to aggregate this information. There is example with the first stage where we used MPLS flag for user identification, and there is a query if we are interested in aggregated data for one user. On the next slide, there are some outputs. They are quite ugly, but I think you will understand it. There is a command line at the top, And in this filter, you can see that we ask for a user with some identification that's ID is 183. And we can see in the list that this user used more address in the communication. Doesn't matter whether the user was connected in this network, on that network, we still have one identification of these users. Doesn't matter whether the user used IPv6 or IPv4 protocol, we have all this data in the one output. There is another output. We have aggregation. We are interested how many data particular user transferred over the network, and doesn't matter what connection they use. Doesn't matter whether they use phone or their laptop or their desktop. We have all this data in one output. So, future work. This system works. We running this system approximately 1 year at our university, and I think it works pretty well. What are next stage? Problem I mentioned, we raping MPLS flag in NFDump tool, so it doesn't look good and it's not okay. So we created patch for NFDump that extends the number of fields that we can store in this data, and currently we can ask for this using this example. Another patch that we have for NFDump is not directly related to this project, but is kind of progress bar. Many of you know the situation when you put some query into data, and doesn't matter whether it's an NFDump or something else, and you don't know whether the results will come in 5 minutes or in 5 days. So there is some progress bar that show you how many data was processed, and you can guess how long this query will take. It's not problem for command line tools, because you can guess the time for processing from the amount of data you queried for, but it's important for some interactive application where another user works with this interface, and then they usually don't care about how many data they will process. They put time window, for example, 1 month and 1 IP address, and they are surprised that results will become in 2 weeks. So this should solve this problem somehow. And another problem is NAV. Some parts of NAV are written in Java. It's a little bit complication. Fortunately, the developers, I think you will talk about it later, move this code into Python, which is, I think, much better than Java. Future work, another problem, also not directly related to this project, is secure and reliable transfer from the data from the Flowmon probes to collector, because there is a problem. If something happens, we usually use for transporting this network data ordinary network as we use for normal communication. And if something happens in the network, we lose this data today because they are normal UDP traffic. And if the connection is lost, we also lose this data. And it's the exactly moment when we need this data to analyze what happened. And is the idea of this part to make some small buffer next to Flowmon probe, and if the link crashes, we store this data for a while, and when this link is correct again, we put this data into collector, and we have this data for later analysis. Okay, that's all. I think I was very fast. Yeah. So if there are any questions, we have 20 minutes for questions. There are no questions. Yeah.
In your network, you are using IPv6 for your users.
Yeah.
Right? And what methods are you using for addresses for ping addresses?
Yeah.
Or
We experimented with both with DHCP version 6 and Slack, but current status of DHCP is very bad due to this do-it. So we said, oh, we can leave it on the Slack because all platforms platforms support Slack, and try to solve these problems with identification in other way. I was in this project. So currently we prefer Slack in our network.
and as I know, you cannot give default gateway using DHCP version 6.
Yeah, it's not possible today. It's
And you can't give DNS with using route advertisement.
today, no, there is another problem. Almost there are no platform that supports these DNS servers. Currently, we leave these DNS servers for through IPv4. And in some, if administrators of the local network want to experiment with IPv6, they usually use DHCP over DNS servers over DHCP version 6, but only for this purpose of name servers. Another question?
How large is your network? How many active
It's I rather say in the number of users. We currently have about 20,000 users, and the biggest part of the network is the student dormitory, where we have approximately 6,000 or 7,000 users.
Do you do network address translation on your network?
No. We have a B block of address, so we don't have to do address translation yet. I think yet.
Question to you, comment about the privacy side of things. How long do you keep those enriched net profiles?
Yeah. So we try to keep as long as possible, and currently the data store is about 10 terabits, and we can store about 1 year. But some of the data are duplicated. We have some other project on this server, so the net flow data are approximately 50% of that amount.
In a lot of European countries, there are legal requirements about how long a service provider can keep those things to protect the user, because users have a right for their activities to be forgotten.
In our
maximum is 1 year in France.
Yeah. We don't have a problem at the university. There are two things. We are not public operator. There are different rules. We are closed private network, so these rules are not applicable for this kind of network. And in our country, there is a big discussion exactly on this topic. I think it's just the same around the whole Europe.
Other questions? I have a question. Since we have the developer of NFDump here, have you made some modification? Has there been discussions?
Yeah, I think we were in touch with that, so I think.
Are these modifications considered a good idea, and how do you see this from your perspective?
Well, quite honestly, I'm not aware of getting any patches from Dev concerning these user IDs, but we definitely can talk about that.
Yeah.
If there is a generic way in having, for example, that problem of tags or tagging.
Yeah, I think, because I think that idea can be used generally, extending by
else than a tag.
Yeah, exactly. It's just tag and number,
so
and
why not make it in a generic way?
Yeah, it was the way how we exactly thinking about this problem.
And you have made patches, and they maybe won't work with the new version of NFDump.
Yeah, it's a problem of patching everything. If you create some patch, you have to keep up to date, and it costs a lot of effort. So if we if we will find way how to extend, for example, existing implementation of NFDAV of this feature in generic way, it would be great. We will be very happy.